Hello everybody, my name is Andre and I will present today a sub-proposal called metafeeds under the umbrella proposal of secure partial replication. Now I am not the originator of this idea, Anders is the originator, but the idea with these meetings and these presentations is that people who are not entirely familiar with the subject try to present the subject so that we gain common understanding. Me and Alexander got together and we made a synthesis, and I am going to present that synthesis. So currently in SSB, all of the feeds have the same property, which is they are using the ED25519 cryptographic scheme as their identity, and they are of unbounded length. So the messages keep on getting appended to the feed, and it doesn't have a limit, it keeps on growing. And the messages appended to this feed are of various types. So the type there is really unstructured. There is no predefined schema, no predefined purpose for each of those messages. They are as diverse as it can get. So this creates some problems. The ED25519 identity becomes coupled to all of that content, and we don't have a way of abstracting the identity from that content. But more importantly, the main problem is that these feeds keep on growing, so obviously replication gets proportionally heavier the more it grows. And the messages on the log being of unstructured format, replicators don't have, or peers who want to replicate this identity don't have a choice to replicate some messages and not the others. So some message may be very application specific, but the replicators, no matter what application they're using, have to replicate all of the messages. It's either all or none. Now it's actually fairly easy to split the content to separate feeds so that you would have structured feeds specifically for some types, but the issue is how do you tie all of those different purpose-specific feeds into one common identity. That's actually the main problem, how to basically, so splitting is not the hard part. The hard part is linking all of those identities and feeds together. So the solution with metafeeds is in two parts. There's the hierarchies and the kinds. So the hierarchies means that we will create a tree of feeds where there's a root feed and subfeeds. So the root feed, it's a single feed. There can be no more than one. And the subfeeds are always, they're recursively structured. And there's kinds of feeds. There's three of them. There's the meta feed, the content feed, and the index feeds. So the root feed is necessarily a meta feed. Its kind is a meta feed. And it functions as the identity of this person or this user. So the ED25519 scheme of that, or key pair of that root feed or meta feed is important to identify. Now the subfeeds are going to be either content feeds, index feeds, or other meta feeds. To talk a bit about these kinds, a meta feed publishes only metadata, or essentially data about other feeds, about these subfeeds. And the content feeds publish messages with actual user content, such as posts and abouts and votes and Git updates. Now, index feeds is a rather new idea. It will publish messages which point to messages on other feeds. Essentially, a message published on the index feed will be quite small, and it will have only a cipher link that mentions a message on another subfeed. For instance, you could have an index feed that displays cipher links to all of the about messages about me, and then I know that this cipher link points to about messages that are in a subfeed that is dedicated to the actual content of about feed. So there's no actual content on the index feeds, only cipher links, but they are useful in the same way that a database index is useful. So let's talk a little bit about this metafeed. How does it look like? It uses the hash key derivation function to generate a seed for the ED25519 identity of this metafeed. And here's a little example in JavaScript. And the schema of all of the messages published on the metafeed are of the following formats. So they have to follow a specific format, and that format specifies basically 4 things. So the metadata has to basically cover what is the subfeed, essentially its identity, and the lifetime means are we creating this subfeed, or are we sort of destroying it or putting a tombstone? And then we also have to specify what is it for. Is it a content feed? Is it an index feed? Or maybe something else? Maybe we could have something else in the future, other different purposes. And also the format of the messages. So typically we've always had the JSON stringified V8 engine specific encoding of the messages, but we could have something else. And this is the purpose of that field. So in practice, it looks something like this. This is what a message published on a metafeed look like. It has type that says here is an operation on the metafeed, and it says the identity, the lifetime, the purpose, and the type. So lifetime is obviously not the field lifetime. It is something like operation add, which means we are creating a subfeed, and purpose is purpose, and feed type is the type of the feed. Here, classic means the JSON stringify using V8 engine semantics and so forth. So how could we use this idea of metafeeds? One main case is for partial replication. So given an old style SSB feed, so currently used in production, let's call it main. So what we can do is that the metafeed can be created, and it can publish a metadata. It can publish a new message that says main belongs to me as a subfeed. And then main can recognize and also publish a message on main that says that I belong to metafeed. So then now they're bidirectionally linked. And then the metadata, the metafeed can create a new, let's say, index feed that's also a subfeed. And this will be actually, this index feed will point to about messages on the main feed. So now if someone wants to like partial replicate only about messages, then they can see the index feed, they can verify that it actually belongs to the main through this metafeed, and then they can replicate only about messages, and they can have a cryptographic, verification that this is actually coming from the author who I know. Another use case for metafeeds is actually, so the interesting thing about metafeeds is that they enable many use cases, even though we're designing this for partial replication. So one of these is called same as, or basically multi-device support, where you can have 2 old style means running in production, feeds, one of them desktop, the other one mobile. Now the metafeed can publish a message that says that desktop is my subfeed, mobile is my subfeed, and then each of those, desktop and mobile, can also create messages that say that they belong to the metafeed. And now people who replicate desktop can also see the presence of the mobile. So obviously people who replicate the desktop will see a message on the desktop feed that says it belongs to the metafeed, and then they can go check the content on the metafeed, they can discover about mobile, and in this way you can sort of tie all of this together. Another use case would be actually to migrate to new feed formats that are better to implement in many languages. And you can do this in a backwards compatible way because you can keep both old and new feed formats running together. So you can take an existing old style feed let's call it main, and a new style field called neo, and you can make the meta feed have them as subfeeds, and then they also now they belong to meta feed, and now anyone replicating the main feed can discover through the meta feed that the neo feed exists, and if the application supports reading messages formatted in that new format, then they can replicate that as well, and then they can support that. So basically the content would be mirrored exactly on main and neo, but it gives you a different way of reading the data. So one day you could drop replicating main if you don't need to support that anymore. So there's clearly a lot of nice applications for this idea, but there's also some open questions. For instance, what happens if you want to do ephemeral feeds, right? So this means that you would create many subfeeds that are short-lived, and because the root feed or the meta feed is not partially replicated and it doesn't support deletions, I believe, then over time the meta feed may start becoming quite large, and it may be of unbounded length. So the question is, how do we sort of bound the length of the root feed in order to avoid heavy replication? And do we even support ephemeral feeds? That's like an open question still. The other question is, what happens when the root feed becomes vulnerable? Do we throw everything away? Do we have any way of guaranteeing that this identity will survive for a long time? Can we refer to this identity in a non-fragile manner in the long term? These are questions that we don't know answers to yet. And finally, one question is the Jains Paradox, where, similar to the usage of coal as fuel, they thought that if you increase the efficiency of using fuel, you would use less fuel, but in reality, more fuel ends up being consumed. And now, if you apply this idea to partial replication and storage, our resource here is storage. Now that we are able to more efficiently use the storage, we end up opening ourselves to new use cases that we very easily sort of neglect storage, and then we may end up using more storage than opposed to using less storage. And I guess the ephemeral feeds was one of these cases. But overall, the idea looks rather solid, and there's more ideas in this link, and I hope you can check it out later, and hope this was useful. Thank you.